Hi, I'm Miss H, and today we're going to be looking at phases of matter. You've probably heard of the term phases of matter before, or maybe you've heard states of matter, and wondered how they are defined. Phases of matter are defined by four of the physical properties of a substance. A physical property is any property that we use to characterize matter, energy, or the interactions between them. Most physical properties are easily observed with the naked eye, such as color or shape, or with the aid of a scientific tool, such as temperature and volume. The four properties that we use to classify the phase of matter a substance exists in are volume, shape, particle arrangement, and the amount of energy in those particles. Do you know what the three phases of matter that are commonly found on Earth are? Most of you probably answered solids, liquids, and gases, which is the correct answer. Now we want to look at some more detail of these properties. The volume of an object is the amount of space that it takes up. In this case, what we're looking at is, does the amount of space that the object or substance occupies change when we change its container? If we're looking at a solid object like a marble, if I move it from one container to another, does the amount of space that that marble occupies change? The answer is no, it stays the same. So we say that marbles or solids have definite or fixed volumes, meaning that the amount of space that they take up does not change based on the container that they're in. I can look at the same marble again and say, does its shape change when I move it from one container to another? Again, the marble's shape, like all other solid objects, does not change just because you change the container it's in. So it also has a definite shape. The reason why solids have a definite or fixed volume and shape is because the particles are very close together and they're very organized. You can think of the particles in a solid similar to soldiers who are standing or marching in formation. They're very close together and they're in nice, neat rows, or very organized. And the reason why this is possible is because solid particles have a very low amount of energy. They basically just vibrate in place. If we move over to our liquids, such as taking water and pouring it from a graduated cylinder to a beaker, does the volume or the amount of space that water takes up change? When you first look at it, it might look like it changes because a graduated cylinder is much taller than a beaker. But if you read the actual measurement on the side, you'll see that they both read the same amount. So the amount of volume does not change, and therefore it has a definite or fixed volume. However, the liquid takes on the shape of the container it's in. That means that it has an indefinite or flexible shape. The reason why liquids have a definite volume but indefinite shape is because although the particles are still close together, they're now random. You can think of the particles in a liquid as being similar to students in a hallway during class change. They're paying enough attention to where the others are so that they don't run into one another, but they're not actually moving with one another. They're just kind of moving past each other. And this is because, again, the particles in a liquid now have a medium amount of energy. So they have more energy than that of a solid. Finally, if we move on to our gases and we think about something like a balloon that you filled with air, if you take that balloon and you put it into a freezer, what's going to happen? Eventually the balloon is going to shrink down. If I take that same balloon and stick it out in the sunlight for a couple of hours, it's going to start to expand and eventually may even pop. So we say that gases have an indefinite volume because the amount of space that they take up can change. Similarly, if you think about that balloon again, I can squish the balloon, I can stretch the balloon, I can change the shape of that balloon. So they also have an indefinite shape. This is because the particles are now spread out and also random. I like to think of this as you've given like a group of kindergartners or other group of people a lot of sugar or caffeine and let them loose in a place like the gym. They're just going to be bouncing off the walls, bouncing off of each other, just kind of running all over the place because they're going to have a lot of energy. And it's the same thing with the particles in the gas. So to summarize, solids have a definite or fixed shape and volume. The particles are very close together and organized. And the particles have a very low amount of energy. They basically just vibrate in place. Liquids have an indefinite or flexible shape, but definite or fixed volume. The particles are very close together, but now they're random. And they have a medium amount of energy, so the particles are actually going to kind of slide past one another. Finally, our gases have an indefinite shape and volume, meaning that they have a flexible shape and volume. The particles are spread out and random, and if you don't have a lid on the container for the gas, they'll escape out of the container. And that's because the particles have a very high amount of energy. They're basically going to be bouncing off of one another. Now you may be asking yourself, is all matter in the universe either a solid, liquid, or gas? These are very common on Earth. We see them all the time. We're used to dealing with them in our everyday lives. However, most of the matter in the universe actually does not exist as a solid, liquid, or gas. It exists in a phase called plasma. Plasma is very rare on Earth because you have to take a gas and make it super hot. One of the only places we see plasma on Earth is in the form of lightning. However, all of the stars, including our sun, exist in the plasma phase of matter. There is also a fifth phase of matter called the Bose-Einstein consolidate, or BEC. You take a solid and you cool it down to almost absolute zero, and you would have the BEC state of matter. It pretty much only exists in a laboratory, so we're not going to be too concerned with it for our class. That's pretty much everything you need to know for phases of matter for our class. If you have any questions, please feel free to send me an email.